Today, I am speaking with Martin Fouilleul about his very ambitious project, Orca, which aims to create a cross-platform target for creating graphical applications. Martin has experience as a sound engineer, which he is a field he worked in for 7 years, doing work in recording and mixing music and developing custom software and devices for digital artists and electronic musicians. He then went on to study acoustics and signal processing and computer science at Orca and completed a PhD there on a temporal programming environment for live shows and art installations. And now Martin is working full-time on Orca. During this conversation, we touch on a number of topics related to the project, starting with the origin of the Orca project and then the roadmap for the project, including where it's at now, but also the long-term vision. We talk about how the architecture of Orca attempts to address its problem differently than previous related technologies like Electron and the JVM. And Martin gives us a little bit of the history that leads us to the modern web browser's current architecture. Finally, we spend some time talking about what work is being done on Orca right now and what's coming up in the short term for the project that we can look forward to. I'm super excited to see where this project goes, and I think this conversation was pretty interesting. I hope you will too. Enjoy. All right, I'm here talking with Martin today. Martin, thanks for being here.
Thanks for having me.
Yeah, so you were connected to this Orca project, which got announced, I think back in June was when the first post came out, but it's been brewing for a while, is my understanding. Before we talk too much about the project, can you talk a little bit about your role in the project? You're writing the posts, I presume, and you're kind of leading it in some ways. So what is your relationship to the Orca project?
Yeah, so I'm leading the project. It started as a jam project back in 2022 during a handmade network reinvention wheel reinvention jam. And then it has developed into something bigger. So I'm leading that, but I'm having a lot of help from people in the handmade network. So I'm also writing the post and doing all the communication around that project and its goal, etc.
Gotcha. Okay, so you mentioned that this project started as like a jam project that you were doing back in the 2022 Handmade Network Wheel Reinvention Jam. Could you talk a little bit more about what the origin story there in that project was? How did you come up with that idea, and what came out of that jam by itself?
Yeah, sure. So we started by just, I guess, chatting in the Handmade Network Discord around summer of 2022, and there was a lot of recurring discussions about what's bad with the web, basically, and what could be done. And these discussions were interesting because they did go a little bit further than mere web dev sucks. That was kind of the prevailing discourse before that. And so admins decided to make a dedicated place to discuss that problem, and they created a channel that was actually whimsically called Future Web Committee. And so there was both, I guess, stimulating discussions, but also intense bike shedding. And we kind of realized that no two people agree on what the web is. And around the same time, late August 2022, there was that Wheel Reinvention Jam, which is a programming jam where I guess the tagline was turn a fresh eye to solve problems. So I decided to explore one specific aspect of the problems with the web, which was cross-platform sandbox application distribution. So I made a prototype of a launcher/sandbox for WebAssembly applications where you could transparently download and run an application from a URL, and you could use it as a transient web application Like when you close the tab, the app is gone, or you could click on a button to cache it into a local application library and use it offline. So that was the Jam project, and that gathered some interest. We began discussing and refining the idea with the Handmade Network admin team, and we decided to make it a bigger initiative supported by the Handmade Network. So at the same time, I was finishing my PhD, so I didn't work on Orca for a while. I finished the PhD in January, so I've been working on it since then. We posted the announcement and the roadmap that was beginning of June, and since then I've been joined by a very small core team of volunteers from the handmade community, and yeah, then we are planning to open the code base and have an early minimum viable products around September for the upcoming Whale Reinvention Jam, so that people can target it at their jamming platform. So that's kind of the genealogy of the whole project.
Yeah, that's excellent. And before we go on to talk about the project, you mentioned that you finished your PhD, which congratulations on that.
Thanks.
And I guess I'm a little curious. Do you feel that, because we haven't talked about this on the podcast yet, but you and I have discussed before sort of what you were doing there, and I'm curious if you would like to explain slightly what that was about, and do you feel that it is at all related to this kind of problem? Are there connections, or is it kind of just happenstance that you went from one interesting project to another and they're not really the same thing?
Yeah, so, well, maybe just to give a little background, I didn't actually start in my professional life as a programmer. I was a sound engineer, and I had my own company and mixing studio for around 7 years, doing recording, live shows, and stuff like that. But I was always programming on the side, and I even got to develop custom software and custom devices for digital artists and electronic musicians. And so at some point, I wanted to do that more. And that's where I got back to studies at IRCAM, which is a lab focused on music technologies with both researchers and artists. So that's where I did my PhD, which was about developing a visual programming environment for temporal scenarios of live shows and art installations. Basically, that was a platform that helped you program and control the timing of technical devices involved in a show, so like lights, soundtracks, whatever, and synchronize them with live performers. So that's not at all directly related to the Orca project. However, I'm very much interested in new ways of programming and new ways of making application compose together to build new workflows and stuff like that. And part of the Orca project in the long term actually addresses that kind of problems.
Yeah, I was curious if you saw that connection in the same way I do, because there's definitely a big gap between working on something like a visual programming system, which is a very different way of coding, and Orca. We'll get into a little bit more what Orca is, I think, next, but if I understand correctly, it's definitely meant to be something where you could program it from just standard typical programming tools we have, like a programming language, so there's nothing inherently visual programming about it. But the fact that there are ideas like transient applications that can connect to each other through Orca, which is reaching farther into the vision, and we'll kind of plot out all of that and where you're thinking about putting each of those pieces. But that idea of those pieces composing in new ways feels to me like it's still quite linked to that sort of creative changes to the way we code. And it sounds like you're kind of thinking of it in a similar vein, if I understood what you were saying correctly.
Yeah, definitely. And also, I think, so Orca is like the platform that, so it's a platform to develop and distribute and run cross-platform sandbox graphical applications, but it's also meant to be a platform with tooling around it to help you develop and debug those applications. And we are actually quite focused on the idea of making better ways to visually understand what your application is doing, how it is interacting with the runtime, how it is interacting with other applications, why it is rendered the way it is, and stuff like that. So I would very much like that the Orca environment to be integrated with those kind of visual tools that give you feedback during the development of the project. And then there's a part about application composition, which is trying to actually take the more interesting parts about the web around like indexing and transclusions and stuff like that, and apply that not only to documents but to applications. So yeah, that is very related to new ways of developing and interacting with programs in that way.
Yeah, so I think now would be a good time to sort of lay out your roadmap, which is broken up into stages, and then we can zoom in more on those stages and explore what you're building out. So can you give us the outline of sort of what is the stage 1, stage 2, stage 3 thing? And for anyone listening, this is all explained in the original Launching the Orca Initiative post, so I really recommend you go and read that to understand the outline better. But basically what I want is just a sort of broad strokes to contextualize as we talk about more what Orca is. And I think like especially what's going on in these 3 stages sort of breaks down like building up different aspects of what makes it an interesting project. So like stage 1, can we start there and sort of spell out what you're thinking of building at each part?
So there are I can like just brush the 3 stages. There's a runtime, a launcher, and what I call the platform. So stage 1 is the runtime. And the idea is to have, you can think of the runtime as a handmade electron, if you will. The goal is to easily produce cross-platform standalone applications that run on several different OSs. So we're using WebAssembly, so you can use the language or tool chain of your choice, to provided that it can target WebAssembly. And we also expose a set of platform APIs for applications to target. And there's a runtime for each underlying native platform. So in this way, from a bird's eye view, it resembles Electron. It will wrap the WebAssembly bytecode you wrote along with the runtime and all the app's resources into a self-contained application that you can run on a native operating system. So that's the first stage, to get all the kind of APIs designed and have the runtime capable of running those applications. So that's where I guess the most immediate value is for developers, because you just develop your application, you target that platform, and it spits out 3 or 4 different applications that can run on macOS, Windows, Linux, etc. So then we can talk about stage 2, which is the launcher. So one problem with Electron, for example, is that you end up with tons of duplicate copies of Chromium all around your computers. There was a tool that showed you all the different instances of Chromium on your computer, and it can be quite a lot. So that's obviously something that is annoying and that is wasteful. There is also the fact that each application comes with its own version of the runtime, so it's kind of ossified in that way. and runtime can get old and not be updated and stuff like that. So the idea is that we have a launcher that is sharing the runtime between application that can have multiple versions of the runtime, and applications can declare which minimum version they might need. So we can do versioning. We can also keep multiple versions of applications into that launcher. And the launcher resembles more what I did during the Jam project, which means it allows you to transparently download and open and run applications from a URL. And then you can use this application in a transient way, like you would for a web application, just visiting a web page, doing your stuff, and then you close the page and it's gone. Or you can have persistent application, and the launcher exposes you like your own library of local application that you can use offline. So it has a bunch of interest. There's also another interest there, which is that if you download a standalone application that come with the runtime, then the sandboxing argument is kind of moot, because you get the application from some random developer in the web, and the runtime could have been tampered with. So you have to trust the developer in the same way that you would trust a developer when downloading a binary. So with the launcher, you trust one source which provides the launcher, and then you can download any number of random applications from the web, and it runs into that launcher, which, if you trust, sandboxes all these applications the same way a browser would.
Yeah, that makes sense. I had actually thought about that, or I think this was in the post perhaps, but I hadn't appreciated the fact that you don't really get the one of the promises of the browser, which is something you talk about, or the promises of the web, which is something you talk about in the Orca initiative post, is that you can use an application without worrying too much about how much damage it can do. And I had not thought about the fact that actually the launcher is an important part of that, because otherwise you're downloading the whole thing every time, and possibly each download could be tweaked, and the launcher gives you a way to guarantee that something's actually running in a sandbox, so long as you trust the launcher.
Yeah, exactly. And that promise holds just because, like, the browser comes with your operating system, and you can trust it by default. But if you had to, like, if you download an Electron application, you can't have that same guarantee, or at least you must, like, distribute your trust among different actors.
And then you have stage 3, which is, I know this is getting pretty far out there, but can we touch on what your vision is when you build even past the launcher into stage 3?
Yeah, so that's the longer term vision, which I'll call the platform, for lack of a better name. And so if you think about it, once you have a launcher that centralizes runtimes and those versioning, and all application use that launcher, and they all use the same portable bytecode formats, and they all use the same API, you are kind of in the same situation as an OS would be. So you can start providing OS-like services. And that's where all the interaction and composition between apps comes on. And so, like, the goal is not to build a browser, like an operating system on top of an operating system like the browser is, but it's more like having all those kind of application which seems like they are standalone and isolated, but they are all using the same launcher behind the scenes. and the same runtime behind the scenes, and they can communicate. They can be composed to form little pipelines for work that you want to do, and they can be transcluded into each other. They can index into each other, and so you are much more in much more interconnected world between applications. So, for example, to make this a bit more concrete, I guess you could imagine an application that's meant to view text documents, and then you want to support some tabulated data into your text document, or some data that is formatted in some way, maybe with Markdown or tags or something. And you could call into another application that's meant to view that tabular data, perhaps spreadsheet application, and embed it into your original text viewer. And so you can compose different viewers like that to make essentially more complex viewers for for richer documents and for aggregating different kind of media. So application could use parts of each other and talk to each other in a way that makes developing complex viewers for complex multimedia dynamic documents easier than it is now, where essentially you have to pile everything on top of each other and make a very complex system that supports all the cases. And in that vision, you would more have like components that can compose in an interesting way and allow you to view richer and more interesting documents.
Yeah, and I think, I mean, when I listen to and think about that vision for stage 3, it sounds sort of like what I think of as the holy grail of a new, more connected, interactive and creative computing system. And in a way that makes it sound far-fetched. But what I think is cool about the Orca project is that when I look at your path, it looks like a reasonable path to try to shoot towards that goal. So I've definitely been someone who's been trying to figure out how to put pieces together in a way that you would get this sort of interconnected multimedia aggregating kinds of effects. And I think that what's pretty fascinating is that, you know, as I've tried to work on that, I always bounce off of like, wow, it's a little hard to figure out how to organize all of it. And the story in Orca sounds very plausible. That's what I think, to me, is so interesting about it. But it's still quite a long ways out there, and it's such a sought after goal, I think, in some circles, that it's hard to immediately assume that like success is inevitable to get to that stage. So I think, while we could spend more time thinking about how that could go, I think it's probably makes more sense to take that vision and say, like, that's kind of motivating all of this, but there's a lot of work to do to actually get there. And then we could spend some time talking about, in more detail, what's happening right now to build out that first stage that's like a stepping stone in that direction. Does that sound reasonable?
Yeah, sure.
Awesome. So let's just start with sort of detail. We talked about in stage 1, it's this runtime. We know it's WebAssembly based, and it's sort of like a new handmade Electron app bundler. So I think one interesting angle to this is to compare it to similar things that exist, maybe starting with Electron, and think about what you're doing in ways that are different that will make this have a different trajectory than those technologies that have done something kind of similar. So why don't we start with Electron and talk about that? Well, in what ways does this differ from just making an Electron app?
Yeah, so Electron is a similar idea if you look from afar. And when chatting about Orca, we sometimes call the runtime a handmade Electron. But really, Electron it's really a browser masquerading as a native application. So it kind of inherits the same technological baggage, and you still have to deal with all the problems with come with the browser, which we can dive into that if you want, and all the problems with the way web technology is architected and layered. So maybe it's worth going back a little bit and talking about like the problems with the web, because that are the problems that Electron continues to carry, I guess.
Yeah, absolutely. Why don't we do that? So, an Electron app is just basically the entire browser stack, but separated from the browser and running a specific web app. So, what
Yeah.
is the architecture of the web, sort of the web application that is different, or that it causes problems that you are trying to correct? I guess is what you're saying we should talk about, which I think sounds good. Go ahead and unpack that for us.
Yeah, so it might be interesting to talk about like the big problems with the web. And one big problem for me is that it's kind of a layering problem, if you will. The web is layered the wrong way for historical reasons, and maybe I'll just go a little bit over this kind of history. Maybe that's a little bit of a segue, but it's an interesting thing to understand why the web and the browser came about how it is, and why that is a problem now.
Yep, sounds perfect.
Actually, the web started as the idea of a kind of universal interconnected knowledge base, and this idea can be traced much earlier than Tim Berners-Lee proposal in '89. So you may have heard of this essay by Vannevar Bush in 1945 called As We May Think, where he kind of imagines a machine he calls a MEMEX, which is a personal mechanized desk to store and retrieve information. And that the kind of first conception about a way to link information into what he calls personal trails. So you have branching streams of interlinked information that you can share with others. And the whole idea behind that was extending human intellects, both individually and collectively. And then the first try at implementing that, maybe NLS by Doug Engelbart at SRI. So he built that system where every piece of information can be hierarchically organized and linked together, and try to realizing that vision of the MEMEX. And that gave that was at this occasion he showed that system in a demo that's called the mother of all demos, where he showed all kind of very innovative technologies for the time. And that's kind of the first iteration on the ideas of what the web could be as a knowledge base. And that later influenced Xerox PARC, which later influenced Apple, and so on. Another initiative in that vein is Ted Nelson Xanadu, which started in the 60s, I guess, and is the one who coined the term hypermedia and hypertext. And then comes the proposition of Tim Berners-Lee, Information Management, a proposal in 1989. And that was the idea of making a documentation database for researchers at CERN and other labs around the world. And in many respects, it's less ambitious and more ad hoc than the previous two attempts, but that's the one that sticked. So you have that idea of the web is interlinked documents, it's a knowledge base, but then very early you have a desire to make web pages more multimedia and more dynamic. And actually that's very early in the life of the web. So as early as 93, 94, you have a load of server-side scripting languages like Python, Perl, Ruby, PHP. You have the first beta version of JavaScript is 94. It was called LiveScript. You have CSS in 94. And in 96, you have Java applets, Future Splash, which became Flash. You have ActiveX, JavaScript 1, and this continues on and on. So from the beginning, there was that desire to make web pages dynamic, and up until today's, where now we can make complete applications on top of that stack. But the drawback of all of that is that it has grown out of proportions by stacking layers upon layers of complexity to basically make it do things it wasn't designed to do at all in the first place. And the choices, the original choices of the fundamental layers was never really rethought with insight of history and in the light of this widely different use case, which is making application and not only making a worldwide database of documents. So all of that to say that in my view, there's a layering problem. You have a very specific ad hoc document model at the very bottom of the stack, and you are trying to build applications on top of that. And some of these applications don't even deal with document, or they deal with kind of document that for which the document model is very inadequate. So we have to deal with sometimes unrelated document model. The fact that we have stacked layers upon layers makes for a sprawling mess of like complicated standards, frameworks, and so it's heavier and slower than it should be. There's a lot of indirection, so it's less predictable, so it's junkier than it should be. There's a lot of complexity of indirection. That means security is itself harder to achieve. And the promise of portability is not really fulfilled either. It's not uncommon to have web apps that require a specific version of a specific browser to work at all. And one funny example of that is you can see the paintings of Diana Smith. Her artist name is Cyan Harlow. She's an artist who is doing paintings using only CSS. No SVG, no images, only CSS. And well, that's a tour de force, but that's also show you how it doesn't look the same on each browser. So like the portability argument is not even a really good one. And we could say that that system is so complex that it's not even really good for documents compared to the original version. Sure, you can access massive amounts of information, but like retrieval and knowledge management aspects, it doesn't really address this vision. So the fundamental problem for me is the layering problem and the technological baggage. And if you're gonna import a whole browser into your application and make it masquerade as a native application, you're not essentially solving the problem. You're maybe hiding it or maybe like working around it, but you're still basically using a browser with all the tech stack in there. So that's for Electron. Maybe some other thing we can compare Orca to with are alternatives that don't use the browser and are addressing the problem at a lower layer.
Yeah, I think that I'd be interested to get into that. Before we do, I'd like to take everything you just said and make sure I've processed it correctly. So I'm going to sort of summarize, and you can let me know if I'm following. I think I've got the idea though. So first of all, the history of the web sort of shows us that the web we've got was originally this rather modest idea of we're going to have a database of documents, they're going to be able to refer to each other. Is sort of designed for researchers to keep track of work that other researchers were doing in other labs around the world or something like that. And
Well,
then,
if I may just interject, is not I don't think it was really a modest idea, especially at
okay,
the time,
sure.
and especially if you consider the ideas of Engelbart and Ted Nelson. Maybe the ideas of Berners-Lee were more ad hoc and more motivated by practical problems at
Okay.
CERN. But the actual vision of Engelbart was like really, really ambitious, and he set out to augment human intellect. And so that was not only like sharing documents between researchers, that was like everyone could participate in that interconnected knowledge base, add to it, modify things, be like this was a big dream of making people be not passive consumers of information but also producer of information, as opposed to broadcast models like television and radio and so on. And in his mind this would like really change the way we deal with human organizations, the way informations circulate between inside those organizations like corporations or political systems and stuff like that. So I think that was like really a vision that goes beyond just documents, but documents is all we got.
Yeah, so I think that I was saying the same thing, although I might
Yeah,
have
okay.
phrased it in a way that was misleading. So let me take another run at it. What I'm getting at is the design for the web that we have was not trying to accomplish all of that vision when it was first, like the
Sure.
original design was these simple documents that connect to each other, and there was all of this bigger vision that kind of got imported on top of that. So everything that makes a web page dynamic is sort of features that are pushing around a document model underneath, rather than an application model that that lets you program these dynamic features. It's more like we got the thing that stuck, I think, as you said, was just these static documents, but then we built on top of that the rest of the vision.
Yeah, exactly.
And you're proposing that the reason the web is so difficult to work with, and the reason an Electron app is not something that can lead to eventually all of the nice, smooth, interconnected features of your vision for Orca, is that it's built on this way that's just fundamentally the architecture adopts this assumption that first you have a document system and you push that document around to make it look like an application, rather than just starting with we want to build dynamic applications. That's basically your answer to how it differs from building an Electron app, if I understand correctly.
Yeah, exactly. And yeah, what we want to do essentially is flipping the stack upside down and building first the application layer, and on top of that we can rebuild documents. But applications that don't need to deal with documents, don't need to carry all the weight of that document model. And also we can have vastly different document models that are tailored for different applications. We are not tied to one single document model that must fit every use case.
Right. Yeah, I think that I follow that description pretty well. And I have some follow-up questions about that, but I think that we will get more information about my sort of contextualize my questions if we go down that other path that you proposed first. So besides Electron apps, what are some other things that exist in a similar space as Orca that don't quite have the same problem as Electron that you outlined?
Yeah, so one of the technologies that was used early on to add that kind of dynamic application aspect to the web was Java applets. So we can talk about the Java virtual machine and about how Java bytecode, in a way, we are using WebAssembly, which is also a bytecode that runs on a virtual machine. So that's kind of similar in that way. And Java was also, like Java applets were also used to make the web more like application, like capable of running applications and multimedia programs. So if we take the Java virtual machine, it's actually kind of like conceptually good, and there are some really smart implementations which had big influence in the progress of just-in-time compilers, for example. The problem I see with it is that it's tied to a very specific and very opinionated language, at least originally. And it leaks some of those language concepts into the VM specification. So, for example, garbage collection, a very kind of explicit support for object orientation. And although now you can target the Java virtual machine from other languages than Java, it seems that new languages that target that, like Kotlin, Groovy, Clojure, etc., they are also mostly trying to be compatible with Java or otherwise inherit the same programming culture. Mm-hmm. And sure, you can compile a language that doesn't have all those bells and whistles to the Java virtual machine, but then what's the point? And so I firmly believe that some decisions should be made at the virtual machine level to support a specific language. If it is to be a shared format for a cross-platform application that you want many languages and even languages that don't exist at the time to target, you must not, like, quote unquote, pollute the design of the virtual machine with very ad hoc features that are only tied to some language concept and some programming school of thought, if that makes sense.
Yeah, I think I could buy that in the sense that when you have a system with extra complexity that is there for maybe a good reason because of its initial design. So if we just accept and don't question too carefully whether or not the JVM is a good design for a backend for Java, and we just say, yeah, the JVM is the backend you want for Java on its own, but that means that it's not designed to be simple as a target for, say, C, where now I have to figure out what it means to compile C to a system that has a garbage collector in the back end. And even if I succeed at that, how am I going to interface with all of the APIs that were written in Java is now a new problem that is not sort of handled elegantly by the JVM since it didn't take that as a goal and so on. I could see the ripple of all these extra bits of complexity, making it so that this particular bytecode, even though it gets away from the document problem, isn't an ideal abstraction to making portable applications that you can also build from lots of different ecosystems. Is that sort of the argument?
Yeah, sure. And there is also another thing that is not like really concerned with the languages themselves, but if you make all these bells and whistles into the virtual machine specification, then the virtual machine becomes harder to implement. And so you have less implementations. It's harder to extend in interesting ways or to otherwise modify, or everything you add, even if you can compile languages that don't use some elements of the virtual machine, everything you add in there also adds weight and complexity. So I think it's better to have like a simpler system that is just a way to encode portable executable instructions, and then you can move around, and then you can JIT compile or compile them in one go before executing them on an underlying native platform. But I don't think you would want to make that very complex.
Gotcha. So I think that actually leads to an interesting sort of area of this, which is, since you think that Orca is a better system, or will become a better system than these as it gets developed, I guess that includes sort of some amount of a claim that WebAssembly is a good simple bytecode. And maybe you agree to that to some extent, but it's also not entirely what you would want. So can you comment a little bit? I don't know how much of your work has directly been dealing with this question, so it might be a dead end. But what is it like? Would you say that WebAssembly is a pretty ideal type of bytecode for this? And is that because it has certain design decisions that are ideal for this kind of use case?
Yeah, well, I think for the time being, it's still relatively simple bytecode. It doesn't have like obvious flaws. It has some flaws that are more related to like the memory model. There's not so much a flaw as it is like just lacking a memory model, basically. But as a bytecode for executing stuff and like almost like an intermediate representation of your program that you can move around different systems, I think it's pretty okay. But I will say that in my mind, the specific bytecode we use, the specific format we use to represent programs is not as much important as it is that this bytecode can be targeted by actual languages, and that this bytecode has tooling around it. So we didn't choose WebAssembly because like it's the best bytecode or whatever. We chose WebAssembly because it has traction. A lot of languages can target it, so you can benefit from all the existing tooling. People don't have to buy in like a new language or a specific language to make application for that. They don't have to change too much of their programming environment to start getting value from the project. And maybe some other bytecode somewhere is better designed or has more interesting features, or is I don't know, more easier to git compile or stuff like that. But there's no tooling. There's like one toy language that can target it, and we don't want to sacrifice that for the fringe benefit of slightly better designed bytecode, basically.
Right. Yeah, that makes a lot of sense. So in a way, all of this is possible because there happens to be a bytecode that has gained traction and is also simple enough in its design to actually enable some of this vision to work.
The thing is, so WebAssembly has traction, but it is also evolving, and there are like a lot of big actors that want to push it in a way or in another. And so there are a lot of proposals, and we must be aware of the potential danger of that getting more complex over time, and like having Google add their features in there, and Apple adding their feature, and so on, and ending up with not a bytecode we want, as something more heavy and less performant than what we want. So that's also something we must be aware of. The advantage of WebAssembly now, it's also that it's pretty young, so it's still simple, and we can still perhaps participate in the kind of conversation around what it might become. So actually the project takes off. we will want to participate in those discussions. And then we will assess if it goes in the right way or not, and if we have to use something else, we will use something else. But for now, I think it's a better choice.
Yeah, that's getting tool chains to target it is such a high barrier to entry that it feels like we're in a fortunate time if it's the case that right now there are enough compilers and systems for targeting WebAssembly, and it's simple enough right now to start doing this that like there's sort of a window of opportunity to begin building something with the architecture you've laid out, and that's it's just fascinating. Setting aside the WebAssembly issue for a second, there's the I guess the question that lingers in my head is we've sort of gone over, Electron, we went over the JVM, and I think those are two pretty good examples. There's also we could compare this to why don't I just make a WebAssembly page, and I think you've explained that pretty well when we talked about Electron as well, which is the whole idea of making a page first and then an application inside of it is a part of what you're trying to change. So I think that maybe it's not clear what question I want to ask, but I think that as I'm trying to figure out in my head whether or not I expect that your thesis is correct, I'm trying to come up with reasons for that. So if your thesis is we need to fix the layers and then, all of this other stuff will become possible, I wonder if the layers as they are with documents at the bottom are important for reasons that aren't solved by this. For instance, is it possible, in your view, that while the architecture you've envisioned can be built, getting adoption is going to be much harder because the reason people like to build an Electron app is because they can use CSS to get started, and now they have to become an application programmer just to get started. And what do you think about that sort of trade-off of now the day one process of building one of these apps looks very different, and so some buy-in from the people doing Electron apps might not happen?
Yeah, so for the adoption part of it, it's true that, we'll remove some tools from people's hands like CSS and HTML and stuff like that. I don't know if these are tools they really love, but those are tools they are used to. And as you said, you have to become more of a programmer if you are like writing in language targeting WebAssembly rather than writing CSS and HTML and stuff like that. There's maybe like potential confusion here to clear is that I don't really see Orca as improving web programming, but more as a new platform for people that are nowadays developing native applications and that want these applications to be portable and easily distributable. So that's not exactly the same target at first. And the fact that we refer to the web so much is just due to the fact that people try to use the web as a solution to the same problems, even if it's fundamentally unfit. But we're not trying like to convert web dev to a more native-like application development style. However, I think that if we manage to solve problems at the right layer, this has potential to make it possible to build a better web experience on top of saner tech stack, and to build better tools for actual like what you would now call web pages. That would be like new documents format, new viewers, and I think there's a lot of potential in that new platform for composing pieces into bigger workflows that don't necessarily need the kind of programming expertise and low-level knowledge that you need to make a native application right now. And so I see that as a potential path for moving stuff from the web to the new platform. But this is not really the focus right now. The focus right now is providing values to people that are writing that native application and that want to distribute them more easily to customers.
Yeah, that's a very useful clarification, and the sort of the early target audience isn't web programmers, even though a lot of what you talk about is WebAssembly and sort of fixing the architecture of the web. You're not fixing the architecture of the web for web programmers. That I think settles my question in my head, which is, doesn't this throw away a part of what makes it attractive? And then you're saying, but yeah, but it's, I'm not trying to save that piece. Those people can keep using the web as it is, and maybe someday we can build them a better web, but that's not the actual day one sort of story about what's happening.
Yeah, definitely.
Okay, so I think the last part I'd like to get into a little bit is, instead of talking about the architecture of Orca, the technology, talking a little bit more about Orca, the team, and the project involved, like how it's going to relate to when you start putting this out. I think you mentioned before, but you're planning on getting this into people's hands relatively soon, sometime by like fall this year, so that people could use it in the Handmade Network's Next Wheel or Reinvention Jam. So we're talking in just the next couple of months. So people are going to start becoming developer users targeting this. And then, of course, you'll have end users using apps that came out of the Orca system. So there's going to be all these different people connecting into it. And I'd like to spend a little time talking about how you think all of that is working right now and how it's going to work. So maybe an easy place to start is, could you tell us a little bit more about what's the team like right now, and what is the team working on?
Yeah, so right now, so there's me. I'm working full time on the project, and I'm helped by Ben Business, who is the lead of the Handmade Network. Ruben Dunnington, who is working on WebAssembly runtime. And Ilya Demyanenko is working on UI system and fleshing out our UI system. And we are trying to have that very early minimum viable products for people to use for their jamming platform. So the idea is that it can be kind of minimal and not completely like feature complete and stuff, because it's for a jam, and it's more like you would have a jam for a fantasy console or like a Pico 8 kind of thing. So people can start playing with that early before it's like a full-fledged system, basically, and being familiarize themselves with it and give us feedback. And we also want this to be an opportunity to bring more people into the dev team and motivating people in the Handmade Network community to participate in this initiative. I don't know yet exactly which form it will take, because there's two competing constraints, I would say. We definitely want to involve the community in that initiative. We want people to bring their unique expertise and their whole lot of talents and skills in the community. So, and the project has many parts. There's like the security, there's like UI, there's a whole bunch of different parts that require different skill sets, and we have the people to do that in the community. So we want to have that. At the same time, there's like a pitfall, which is having too many cooks around the pot, and just having that kind of design by committee that would just everyone adds its own preferred features, and there are like intense bike shedding about meaningless stuff, and there's the danger of losing the vision. So we have to find the right balance between those two things. And basically, I think we are just going to move slowly and just let people, like the code will be open source, will be public. People can try stuff, but the core team will likely remain small at the beginning, and we will most likely pick some people with specific skill sets to integrate the core team for a specific task, and then grow step by step in this way. But I think we must be very, very careful about not losing like the vision, like the direction of the project, basically.
Yeah, yeah. I wonder, how do you think about the role of people who are not on your team, but who are developer users of Orca? So they're targeting it, and obviously, some segment of this project is going to have to be the documentation and examples to get them started, and then there's going to be a feedback channel there. And since you have a minimum viable product coming out, I wonder if you have some insights about what kinds of feedback would be most useful and how you plan to communicate that. I mean, this podcast might be one such opportunity, but more in general, what is the plan for having a sort of constant communication between the inside of the team and that like second layer of developers involved in Orca?
Yeah, so one of the problems we're working on right now, and actually Ben Business has done a tremendous job at making it very easy to set up the development environment for Orca for people wanting to work with Orca, like the runtime, and people wanting to make applications. So it's now very easy to just set up your environment and start working. There is a need for documentation. We will start with examples showing how a basic application is structured, and showing you how to do basic 2D vector graphics, 3D graphics, and things like that. But then we will want also to involve the community in support and producing documentations of like second order documentation, if you will. And for the feedback we expect from the jam, I think so there are all kind of platform specific quirks that we can only hit if more people use the runtime. So that will be valuable info that we can't just have ourselves on our small team with a small set of machines. So that's one part. But maybe the more important part is I want people to get the feel of how the APIs will look like, and telling if that's intuitive enough, or if it's confusing, and coming up with use cases where we could like tweak the API, like designing an API involved that kind of a conversation with users. And we will of course do some dogfooding, like building I want to build applications in that system. That's originally why I started working on it. So but everyone has its own like set of habits, and I need to know how other people perceive these kind of APIs that we will have for Orca, because they are a central part of the value proposition of the whole project.
So I think the API is a part of the technical design of all this that we haven't spent a lot of time talking about, and I think I'll leave most of that up to the post you've written about it, because it's going to get very technical. But definitely makes sense that in the early days, feedback on APIs would be useful. So I mean, I definitely am looking forward to getting a chance to try Orca out maybe in September for the jam. I'll probably have a lot of API feedback, but I'm sure that I won't be the only one with opinions. So that'll be interesting to see how that part of this plays out. As we're kind of getting close to the end of the questions I've got here, the last category of question I have is what is sort of the economic plan for this? Do you intend to continue just doing this as a group of volunteers? Do you guys think there's some way that the Orca team could raise money to fund the project? And do you think people targeting the Orca project or targeting the Orca platform will have a path to making money off of that? Will you have like an app store kind of thing, or is it more of a free distribution model that you're going to go for? What do you think about all that?
Yeah, so like right now I'm living off my savings, which will eventually run out. So the question is actually very concrete for me. And I think that um, once we have that minimum viable product, and once people have tried that and see if they're interested, and like we can gauge the interest of people, and they can also express what they expect from the project. I think we'll have to ask for support and financial support, just so that I can afford working on that, like continuing working on that full time. That would be my like the ideal way to support the project, continue to dedicate all my time and energy on the project. And so I think we'll definitely try to raise money among like the community and among a wider audience, and that will probably take the form of donation and Patreon-like model. I do think that it's really important for the platform to be open and to be free. Since if I put myself in the shoes of an application developer, there's a question of ownership between like of ownership regarding the platform you're using. So you don't necessarily want to use a platform that is proprietary, not only because you have to pay something, but because that platform can go away from under your feet at any time. Whereas if that platform is open and can be continued by other means, even if the leads of the project or like the organization supporting project disappears, there's still like all that work isn't lost and people can continue to carry on. So that's much more reassuring for app developers. So I definitely think it makes sense that the platform is open source, but there can be like peripheral business opportunities around that open core. So for example, tooling, like specialized tooling for developers that can be developed either like by us, the core team, but also by any developers that wants to integrate its own tooling into the Orca platform. Since the vision is to have that kind of interaction and composability between applications, that means you can it will be like easy to build tooling that can introspect inside the platform. So that's definitely something we want to encourage, and all that kind of peripheral tooling kind of things can be business opportunities to get some funding, and also like just making application that you sell on the platform.
Yeah, yeah, that sounds like a vision I could get behind. The issue of ownership is pretty important in this. And in fact, I think with a platform like this, when I've been thinking about where it's going. As I said, at this level of sort of the features and the ability for things to compose and all that, that is one holy grail. Another thing that I think is fairly popular in the handmade network are ideas like local first. So these ideas of me having my data on my computer. If I have an application, it shouldn't require me to be online to use it. And you've got those ideas in there. And then there's this open core, so it's a free platform rather than one where some company owns the means of distributing across the entire platform and takes a cut from everybody. And so that's sort of that ownership piece. And it sounds like you're targeting at like hitting a lot of these different points that I think resonate really strongly with me the more I think about what you're going for. So I hope to see that things continue to go well. And if people listening want to follow and know when the MVP is out and get involved in other ways, what are some ways that they should follow the project and get in touch?
So people can go to orca-app.dev. That's a website where I make blog posts. Like there's the announcement blog post if you want to have like a summary of the whole vision. There's blog posts that dive deeper into the architecture and like technical stuff, and there will be more to come. And in that website, you can also subscribe to our newsletter. And so I will post updates on that newsletter. And you can also come discuss with us in the Handmade Network Discord. There's dedicated channels for discussing things related to Orca. You can also find me on Twitter and and write me a message or anything. And I'm always happy to discuss the project.
All right. Well, thanks so much for coming on and talking about all this. I'm looking forward to seeing how this goes and probably talking about it again in the future sometime.
Yeah, thanks for having me.